Something strange is happening with 3I/Atlas. And if you're only reading the headlines, you would never know. An interstellar object brightens again after moving away from the sun. That alone is unusual, but not unprecedented. Yet what followed was a surge of gas, dust, methane, water vapor, and complex organic molecules months after perihelion. A pear-shaped dust structure pointing toward the sun. A sustained anti-tail with no conventional anti-solar tail. Circularly symmetric gas comas coexisting with asymmetric dust morphologies. Large icy grains dominating the coma. No small particle radiation-driven tail. And somehow when the story was reported publicly, the strangest details disappeared. Instead, we were told this was just a comet behaving like a comet, that it had a processed crust, that solar heat penetrated inward, that buried ices were finally erupting, that everything now looks typical. But when you look at the actual observational details, the picture becomes much more complicated. Water gas emissions 40 times higher, methane present despite cosmic ray processing claims, carbon monoxide surviving where methane supposedly did not. Dust grains so large they would have to be millimeter to decimeter scale, possibly even larger, in order to explain the morphology. Violent outgassing required to account for non-gravitational acceleration, yet no microscopic dust particles forming a standard tail. This is not about declaring something artificial. This is about asking whether the full story is being told. Because when a comet produces a long-term, sustained anti-tail that defies solar radiation pressure, when explosive activity generates only large grains and no fine dust, when chemical arguments contradict themselves, that's not a footnote. That's the story. Let's begin with what the media chose to emphasize and what it didn't. The public-facing coverage focused on observations made in December 2025 using the Sphere-X space telescope. The object, already moving away from the sun, exhibited renewed brightening and a surge of gas and dust 2 months after perihelion. Instead of fading quietly into darkness, 3I/Atlas flared with activity, developing a glowing coma rich in water vapor, carbon dioxide, methane, methanol, cyanide, and organic compounds. The explanation offered was straightforward. Sunlight had slowly penetrated beneath the comet's surface, reaching pristine ices that had remained locked away for billions of years. As the energy diffused inward, those buried materials began sublimating, releasing a cocktail of chemicals into space. The comet, having spent ages in interstellar space, bombarded by cosmic rays, was said to possess a radiation-processed crust. Now, with solar heating, the inner layers were erupting. The chemistry, we were told, offers a rare opportunity to compare interstellar comets with those formed in our own solar system. The similarities and differences could help determine whether planetary building blocks are common across the galaxy. That is the narrative most viewers encountered: a brightening comet, a delayed sublimation, a natural process unfolding. But that narrative leaves something out. What was not emphasized publicly were the anomalous morphological and compositional features observed during this same period. The gas comas of carbon monoxide and carbon dioxide were circularly symmetric around the nucleus. Yet the dust and organic continuum formed a distinctly pear-shaped structure with its stem pointing sunward, an anti-tail configuration. No conventional anti-solar dust tail dominated by small radiation pressure-driven particles was detected. Instead, the morphology suggests that the methane, cyanide, and water vapor emissions were tied to very large dust grains. The analysis indicates that these grains must be at least millimeter to decimeter scale in size. In fact, to preserve deep, unprocessed material after prolonged cosmic ray exposure, some grains would need to exceed 10 m in thickness. At the same time, these same large boulders would have to provide sufficient surface area to make the coma 100 times brighter than the nucleus in reflected sunlight. And yet, despite the object undergoing violent outgassing sufficient to cause measurable non-gravitational acceleration at perihelion, no population of microscopic particles forming a conventional antisolar tail was observed. No small particle jet structures, no fine dust signature that would normally accompany explosive activity. Instead, the result is a sustained anti-tail pointing toward the sun composed of large icy dust grains that appear to defy solar radiation pressure. That detail alone fundamentally changes the interpretation, but it was barely discussed. The prevailing interpretation for 3I/Atlas proposes that during its long journey through interstellar space, the object was heavily bombarded by high-energy cosmic rays. This prolonged exposure is said to have processed its outer layers, effectively altering or removing more fragile volatile compounds from the surface. According to this explanation, the radiation stripped away methane and other easily disrupted molecules, leaving behind more stable substances, such as carbon dioxide. This framework is then used to explain early observations in which methane was not prominently detected. The argument goes like this. The outer crust had been chemically altered over billions of years. So, the initial activity reflected only what survived that processing. Only later, after extended exposure to solar heating inside the ice line, did deeper, pristine ices begin erupting, releasing methane, water vapor, carbon monoxide, and additional organic species. At first glance, that sounds coherent. A radiation-processed crust, solar energy penetrating inward, delayed sublimation of buried materials, a natural sequence. But there is a critical chemical tension within that interpretation because carbon monoxide was detected and carbon monoxide is more chemically reactive than methane. If cosmic radiation destroyed methane in the outer layers, carbon monoxide should have been eliminated as well. The mechanism that supposedly erased methane should not have selectively preserved CO. Yet CO appears in the observed gas emissions. That is not a minor inconsistency. That is a chemical contradiction. The chemical shifts did not stop there. Between pre-perihelion and post-perihelion observations, the gas abundance ratios changed dramatically. The ratios of carbon monoxide to water and carbon dioxide to water transitioned toward values typical of long-period solar system comets. At the same time, water gas emissions were reported to be 40 times higher than earlier measurements. That scale of change is not subtle. It indicates a profound alteration in the dominant volatile output of the object. Meanwhile, the continuum spectral signature evolved from approximately neutral to substantially bluer. This spectral shift suggests the presence of greenish olivine, residual ice absorbing amorphous carbon and large silica grains. Crucially, particles small enough to create blue coloration via scattering were ruled out because such particles would be subject to strong solar radiation pressure and would form a conventional antisolar tail, something that was not observed. So the model must simultaneously explain a crust stripped of methane, but not carbon monoxide, a dramatic surge in water emissions, a radical shift in volatile ratios, a blue-shifted continuum implying specific mineralogy, and a dust environment dominated by large grains, not fine particles. All of this while claiming a straightforward natural progression from processed crust to pristine interior. Each piece individually might be accommodated, but together the tension grows. Because if methane was removed by cosmic ray processing, why is carbon monoxide present? If explosive outgassing liberated buried volatiles, why were no microscopic particles generated? If the chemistry now resembles typical long-period comets, why does the morphology remain fundamentally atypical? This is not about rejecting natural explanations. It is about acknowledging that the explanation must account for every observed detail, not just the convenient ones. And once we move from chemistry to dust physics, the improbabilities become even harder to ignore. If the chemical inconsistencies raise questions, the dust physics raises something even more difficult. Scale. The observed morphology indicates that the coma is dominated by large icy dust grains, not micron-sized particles, not fine dust that responds dramatically to solar radiation pressure. Instead, the grains must be at least millimeter to decimeter in size and potentially much larger. Why? Because no radiation pressure dominated anti-solar tail was detected. In a typical comet, small dust particles are pushed away from the sun by radiation pressure, forming a classic anti-solar dust tail. But here, that structure is absent. Instead, we see a sustained anti-tail pointing sunward with a pear-shaped morphology whose stem faces the sun that immediately constrains particle size. Only sufficiently large grains massive enough to resist radiation pressure, could behave this way. But it gets more extreme. To preserve deep, unprocessed material after billions of years of cosmic ray exposure, some grains would need to exceed 10 m in thickness. 10 m. These are not dust particles in any ordinary sense. These are boulder-scale fragments. And at the same time, those same large grains must collectively provide enough reflective surface area to make the coma approximately 100 times brighter than the nucleus. So the model requires enormous grain sizes, significant total mass, sufficient surface area for brightness and structural integrity under active sublimation. That is already a delicate balancing act. But now we add dynamics to account for measurable non-gravitational acceleration near perihelion. Violent outgassing is required. The object's trajectory shifted enough that explosive sublimation is the accepted mechanism for the deviation. Violent outgassing, explosive release of volatiles, rapid sublimation under intense solar heating. And yet, despite this energetic activity, no population of microscopic particles appears to have been generated in sufficient quantity to form a conventional anti-solar tail. No fine particle stream. No radiation-driven dust plume. Instead, the emissions of methane, water vapor, and cyanide appear tied to the large dust grains themselves. The volatile species are associated with these massive particles rather than dispersing independently or attaching to fine debris. This creates a mechanical paradox. Explosive processes normally fragment material across a spectrum of sizes. High-energy disruption does not selectively produce only large coherent fragments while generating virtually no small debris. If anything, fragmentation cascades downward into smaller and smaller particles. Yet the observed morphology suggests that only large grains dominate the coma structure. Millimeter to decimeter scale at minimum, possibly meter scale or larger for preservation arguments, and no detectable radiation pressure-driven fine dust component. That combination is extraordinarily difficult to reconcile because the model must simultaneously accept explosive outgassing strong enough to alter trajectory, dust liberation sufficient to brighten the coma 100 times, large grains dominating morphology, and an absence of fine dust signature. Each of those elements individually is plausible. Together, they strain coherence. And this is where the physics becomes uncomfortable. Because if the grains are that large, if they behave that coherently, if they resist radiation pressure so effectively, then the morphology is not just unusual, it is structurally controlled. And that brings us to the final theme. At the center of this entire discussion is one morphological fact that refuses to go away. 3I/Atlas exhibits a sustained anti-tail pointing toward the sun without a conventional anti-solar dust tail dominated by small particles. In comet physics, anti-tails can occur temporarily due to geometric projection effects, but they're typically accompanied by the standard anti-solar tail, driven by radiation pressure acting on microscopic dust. Here, that second structure is absent. The coma gas for carbon monoxide and carbon dioxide appears circularly symmetric around the nucleus, while the dust and organics form a pear-shaped sunward-pointing structure. No radiation pressure-dominated fine particle tail is detected. The natural interpretation requires that the methane, water vapor, and cyanide emissions are tied to large dust grains massive enough to resist solar radiation pressure. At the same time, these grains must still contain residual ice, as evidenced by the broad H2O absorption feature, and they must collectively account for a coma brightness 100 times greater than the nucleus. So the model becomes very specific. The dust grains are large millimeter to decimeter scale at minimum. They contain volatile material. They resist radiation pressure. They form a sustained sunward antitail, and they do so without producing a fine dust antisolar counterpart. That configuration is acknowledged as unusual. Yet publicly the object is described as evolving into a conventional comet. But conventional comets do not produce long-term antitails without conventional tails. That distinction matters because morphology is not cosmetic. It is physics made visible. When observational details become this intricate, interpretation becomes delicate. The official explanation stays firmly within natural cometary processes. Radiation process crust, delayed sublimation, large grain emission, volatile ratio shifts. No claim of artificiality is made. The framework remains strictly natural. But here is where the tension emerges. If one begins to question whether the dust physics fully accounts for the morphology, if one points out that violent outgassing without fine dust fragmentation is mechanically counterintuitive, if one highlights that methane destruction without carbon monoxide destruction is chemically inconsistent, if one notes that a sustained antitail without an antisolar tail is unprecedented in natural cometary behavior, the discussion moves into uncomfortable territory, not because it proves anything artificial. It does not, but because it exposes explanatory gaps, and within academic structures, explanatory gaps are often managed conservatively. Publishable interpretations must remain anchored in established frameworks. Hypotheses that drift too far beyond conventional models risk professional consequences. The incentive structure favors incremental explanation over disruptive reinterpretation. This is why the broader argument emerges. There may need to be a distinct scientific pathway dedicated to investigating technosignatures or anomalous astrophysical phenomena without the stigma of stepping outside standard cometary theory. A discipline where unconventional possibilities can be examined rigorously rather than dismissed reflexively. 3. Atlas may very well be a bizarre natural object. It may be an extreme, but ultimately explainable comet from another star. That is entirely possible. But here is the point. If you only read the headlines, you would never know that there is a sustained antitail without a conventional antisolar tail. There are millimeter to decimeter scale grains dominating the coma. Some preservation arguments require fragments thicker than 10 m. Water emissions increased 40-fold. Methane appears despite arguments about cosmic ray processing. Carbon monoxide survives where methane supposedly should not. Violent outgassing occurred without producing a fine dust radiation tail. Each of those facts is real. Each of them was observed. Each of them matters. Science advances by confronting anomalies, not by smoothing them away. And morphology, chemistry, and dynamics are not side notes. They're the data. When a comet brightens after perihelion, that is interesting. When it does so while producing a sunward antitail composed of large grains, that is significant. When the chemical explanation introduces internal contradictions, that is important. And when explosive outgassing generates only large fragments with no microscopic debris signature, that is something that deserves full discussion. None of this proves artificiality. None of this proves design, but it absolutely proves that 3I/Atlas is not a trivial object. And when the most anomalous aspects are barely mentioned publicly, people notice because transparency builds trust. Minimization builds suspicion. 3I/Atlas might ultimately fit within natural cometary physics. It might expand our models rather than break them. But if that's the case, then the full complexity of the observation should be front and center, not quietly omitted. This object came from another star. It has traveled for billions of years. It is currently rewriting what we thought we understood about interstellar visitors. And whether the answer is conventional or revolutionary, it deserves to be examined completely. If you want continued updates grounded in the actual observational details, not just simplified summaries, make sure you subscribe. Because in astronomy, the truth is rarely in the headline. It's in the anomalies. And 3, I/Atlas is full of them. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.